Okay, so we have this function, inverse secant of x, and we want to find the equation of the tangent line at x equals to 2. Okay, so the first thing we're going to do is we're going to find the slope. So to find the slope, we need to find the derivative. Okay, so the derivative is 1 over absolute value of x, square root of x squared minus 1. Okay. So then the slope, m, is equal to f prime at 2. All right. So this is 1 over absolute value of 2 is just 2, and then square root of 2 squared minus 1. So this is 1 over 2 square root of 2 squared minus 1 is 3. Okay, so that's the slope. And then the second step is to find the y-intercept. Okay, so to find the y-intercept, we first write down y equals to mx plus b. And then we already know that the slope is 1 over 2 square root of 3. We know that x is equal to 2 because it's given. Now y we don't really know, but y is equal to the value of the function at 2. So since it's not given, we have to actually find it. So this is inverse secant at 2. Well, inverse secant at 2. This isn't one that we, usually know right off the top of our heads. So let's take a look. Let's translate it. Translate what this means. What this means is, this means secant of what angle is equal to 2. Okay, so instead of thinking of it as secant of what angle is equal to 2, let's convert it into cosine. So this is the same as saying 1 over cosine of what angle is equal to 2. Or in other words, cosine of what angle is equal to 1/2. And so now, this is something that we can understand. If you already knew what it was, well, good for you. But if you didn't, now you would say, oh, well, that's pi over 3. Okay, great. So inverse secant of 2 is pi over 3. And so that's what y is equal to, pi over 3. Okay, so let me break this up. Okay, so then what I have is that b is equal to pi over 3, and then minus these two guys. I'm going to move them over to the left side. So this is going to be minus 2 over 2 root 3. I can simplify this a little bit. Just get rid of those 2's there. So then I get that b is equal to pi over 3 minus 1 over root 3. Okay, so then in the end, I get that y is equal to m, which is 1 over 2 root 3, x, and then plus b, which is pi over 3 minus 1 over root 3. And that's it. That's the equation of the tangent line. So here we have a function, 2x plus cosine x, and we want to do several things to it. We want to show that it's 1-to-1. And then we want to find the inverse of this function at 1. And then we want to find the derivative of the inverse at 1. Now, one thing to notice, you remember that for a function to have an inverse, it has to be 1-to-1. But notice that you can't actually find the inverse of this function algebraically. So the formulas that we've seen are going to help us actually find these. So first thing is to show that it's 1-to-1. So remember, for a function to be 1-to-1, what that basically means is that if you have a y value, it can only come from one single x value. So in other words, if you have f of a is equal to f of b, then a must equal to b. So graphically what this means is that if you have one y value, for example, so if you have a y value, it can only come from one single x value. And so, for example, if you've got this y value, let's say that's 3, well, that's not 1-to-1 because this one comes from two different x values. Okay, so this function, this one that I drew, is not 1-to-1, whereas, for example, this function would be, because every single y value corresponds to a single x value. Okay, so we can show this analytically. So what we do is first, we start off with the assumptions. So we go, okay, so f of a, which is just plug in a into these two functions. So we would get 2a plus cosine of a is equal to f of b. So this would be 2b plus cosine of b. So those are our assumptions. Now, this is the usual way to show that something is a function is 1-to-1. Then you do some algebra and then you get that a is equal to b. But there's no obvious way to do that here. But let's try a different way. Using the derivative, we can actually show that this function is 1-to-1. So follow with me here. Let's find the derivative. The derivative of this function is 2 and then minus sine of x. Okay, now take a look here. Notice that this guy right here, sine of x, is always between -1 and 1. Well, what does that mean? Well, that means that this guy right here, if sine of x is always between -1 and 1, to minus that number, that means this guy, the derivative, is always positive. If it's always positive, what that means is that the function 2x plus cosine of x is always increasing, also called monotonically increasing. Well, if it's always increasing, then it would have to be 1-to-1, right? Because it would look, something like that. So, this implies that it has to be 1-to-1. So that was a little unconventional little way to show that it's 1-to-1. So that was good. Now let's do this guy. So let's do part B. What's f inverse of 1? Well, f inverse of 1, this is asking you when the y value is 1, what would the x value have to be? Okay, so the easiest way to do this with these kinds of functions, since you can't actually solve for x, what you're looking for is you're trying to solve this guy. 1 equals to 2x plus cosine of x. So what you do is you just kind of guess. So I would recommend starting with 0, seeing if that works. Then 1, and maybe -1, and that kind of stuff until you get the one that works. In this case, 0 actually works, right? because cosine of 0 is 1, 2 times 0 is 0, so 0 is the correct value for the inverse of f. Okay, now part C says what's the derivative of the inverse at 1. Okay, so to find this, we use our formula that we've been using. This would be 1 over f prime of f inverse at 1. Okay, so we already know what this guy is, right? This one is, we just found it to be 0. And so then what we're looking for is f prime at 0. Well, we actually already found f prime. F prime of x is right here. So f prime of x is 2 minus sine of x. Let me actually just go down instead. Okay. So this is equal to 1 over, the color's a little bit too bright, 1 over f prime, that's 2 minus sine of x. In this case, it's 0. 1 over 2 minus sine of 0. Well, what's sine of 0? That's 0. So this is equal to 1/2. And that's it.